Hello class, welcome to your video notes on lesson 5.2, polynomial division and the division algorithm. In this lesson, we are going to learn about the division algorithm, what it is, how it works, and the remainder theorem. We are going to learn about polynomial long division, how we actually divide polynomials using this long division process, this division algorithm, and how we can divide using synthetic division. And third, we're going to learn how to construct polynomials with given zeros. So here we go. The first thing we need to understand is what is the division algorithm. And I've written DMSB because this is the division algorithm. In elementary school, if I taught elementary school, I would teach my students daddy, mommy, sister, brother. Daddy, mommy, sister, brother. This is the division algorithm, and it goes in a cycle. Daddy, mommy, sister, brother, daddy, mommy, sister, brother. Daddy, we know, really means divide. Mommy, we know, really means to multiply. Sister really means to subtract. And brother really means to bring down. And these four steps make up the division algorithm. So we go back and look at an example that you might have learned when you very first learned to long divide in elementary school. We can use the division algorithm to do this. We would say, first step is daddy, or divide. So I'm going to ask myself, how many times does 4 divide into 2? None. But how many times does 4 divide into 29? Well, 4 can divide into 29 7 times evenly. So I write my answer to my division up above. Then, second step is mommy, or multiply. So I'm going to take my 7 and multiply by the divisor 4. 7 times 4, my answer comes down beneath. I get 28. Third step is sister. Sister really means to subtract. So I'm going to subtract 28 from the number above it, 29. 29 minus 28 is 1. Fourth step in my algorithm is brother, or bring down. So I'm going to bring down 1 digit. So bring down the 3. And now we begin again. Daddy, mommy, sister, brother. Divide. How many times can we say 4 divides into 13? Well, 4 divides into 13 3 times evenly. Then I'm going to take my 3 and I multiply by the divisor 4. 3 times 4 is 12. The next step, sister, means to subtract. So 13 subtract 12 is 1. And the last step, brother, bring down, I don't have to do here because I don't have any more digits to bring down. So you probably learned in elementary school that the quotient, or the answer here, is 73 remainder 1. 73 with 1 remainder, 1 left over. Well, in algebra, we would write this as 73 with 1 left over our divisor of 4. So our true quotient is 73 and 1/4. The remainder goes over the divisor. Okay, so 73 times evenly with 1/4 left over. So 73 and 1/4. That is the division algorithm. Now, when we convert this to polynomial long division, there's a few things that we have to keep in mind. The directions here say use polynomial long division to rewrite the following fraction in the form Q, that stands for quotient, here's your quotient, plus your R, that's your remainder, over D, that's your divisor. Where D of X is the denominator of the original fraction, or the divisor, Q of X is the quotient, R of X is the remainder. So, dividing, our divisor is our big polynomial, And we're going to put that under this division symbol. So 12x to the 5th. When I'm writing this, I need to be sure that my powers go in descending order and that I do not skip any powers. So x to the 5th plus 2x to the 4th minus 36x to the 3rd minus 5x to the 2nd plus 15x to the 1st. And I am always going to go all the way down to a constant. So I'm going to go down to the constant of 0. Okay, in my divisor, I'm also going to write all of the terms in descending order. But if you'll notice here, we are missing x to the 2nd power in our divisor. So I'm going to write that with a 0 coefficient. So I will write 2x to the 3rd plus 0x to the 2nd. I don't want to skip any powers of x. Minus 5x to the 1st plus 0 is my constant term. Now, just like I did in elementary long division, I'm going to follow the division algorithm, daddy, mommy, sister, brother. So I'll start with the term 2x to the 3rd, and I'm going to divide it into the first term, 12x to the 5th. So what is it that I could multiply by 2x to the 3rd to get 12x to the 5th? I know 2 times 6 would give me 12. And x to the 3rd times x to the 2nd would give me x to the 5th. So my first step is dividing. Second step, mommy, is multiply. When I multiply here, I'm going to multiply this 6x squared by every term of the divisor. So 6x squared times 2x to the 3rd is 12x to the 5th. 6x squared times 0x squared is 0x squared. Sorry, 0x to the 4th, adding powers. 6x squared times negative 5x is negative 30x to the 3rd. 6x squared times 0 is 0x squared. That is the result of mommy. That's multiplication. Sister, that means to subtract. Now, when I am subtracting, I do want you to notice how every time I've put subtraction, I've used parentheses. That is important here because when you subtract, we're subtracting every term. So what essentially happens is we distribute the negative into this green polynomial, and it becomes plus a negative 12x to the 5th. Change sign to 0, it's really the same thing. Negative 30 becomes positive 30, and then change our sign there. So we change all the signs, and then we add down. So 12x to the 5th plus negative 12x to the 5th cancels. That should happen every time. 2x to the 4th plus 0x to the 4th is 2x to the 4th. Negative 36 plus 30 is negative 6x to the 3rd. And negative 5 plus 0 is negative 5x squared. That is the result of subtraction. The next step is brother, bring down. So I'm going to bring down plus 15x. So I'm bringing down one term. Now the algorithm begins again. I'm going to say, what can I multiply by 2x to the 3rd that would equal 2x to the 4th? Well, that would just be x. So then I multiply x multiplied by 2x to the 3rd is 2x to the 4th. X times 0x squared is 0x to the 3rd. X times negative 5x is negative 5x squared. And x times 0 is 0x. So that's daddy, mommy. Sister is subtract. So when I subtract again, I'm actually going to go through and distribute the minus, so it changes all the signs inside. And then I combine down. So 2x to the 4th plus negative 2x to the 4th cancels. Again, the first term should cancel every time. Negative 6x to the 3rd plus 0x to the 3rd is negative 6x to the 3rd. Negative 5x squared plus 5x squared cancels. 15x plus 0x is plus 15x. I may go ahead and put plus 0x squared as a placeholder here. Bring down the last term. Bring down 0. Okay? We're going to do this one more time. What can I multiply by 2x to the 3rd that will equal negative 6x to the third. Well, 2 times negative 3 would be negative 6, and I don't need to change my power at all. So now I'm going to multiply all the terms of the divisor by negative 3. Negative 3 times 2x to the third is negative 6x to the third. Negative 3 times 0x squared is 0x squared. Negative 3 times negative 5x is positive 15x. And negative 3 times 0 is 0. That's mommy. Sister, I'm going to subtract the quantity. So I'm going to distribute in the negative. So it becomes plus positive. Changing all these signs. And I noticed that 6x to the third and negative 6x to the third cancel. This cancels. 15x minus 15x cancels, and this cancels. So I'm left with no remainder, but I'm left with just a quotient of what I have here in red. So my answer here would just be 6x squared plus x minus 3. Since there was no remainder, I don't have to write a remainder over a divisor if there is, sorry about that, if there is no remainder. So this part right here is not necessary. I'm just having to list my quotient. Here's another example of long division. It's going to work the same way. So I'm going to begin by writing 6x to the fourth minus 12x to the third plus 5x to the second plus 4x plus my constant of 5. Everything was in descending order and no powers were skipped. As my divisor, I'm going to have 3x squared. I'm going to put a 0 coefficient in front of x plus 1. Now, daddy, mommy, sister, brother, divide. What can I multiply by 3x squared to get 6x to the fourth? Well, 3 times 2 is 6, and x squared times x squared will be x to the fourth. So there's the result of division. Multiply. 2x squared times 3x squared is 6x to the fourth. 2x squared times 0x is 0x to the third. 2x squared times 1 is 2x squared. Sister, we subtract. Distribute the subtraction sign in. So it becomes plus a negative, change the signs all the way across, and add down. 6x to the fourth minus 6x to the fourth cancels. Negative 12x to the third plus nothing is negative 12x to the third. 5x squared minus 2x squared is 3x squared. Bring down one term, plus 4x. Divide again. What can I multiply by 3x squared? That would equal negative 12x cubed. Well, I know that 3 times negative 4 is going to be negative 12. And x squared times x would give me x to the third. Multiply. Negative 4x multiplied by 3x squared is negative 12x squared. X cubed, sorry. Negative 4x times 0x is 0x squared. Negative 4x times 1 is negative 4x. We are going to subtract. So I'm going to change to adding the opposite. Add down, 12x cubes cancel. 3x squared plus nothing is 3x squared. 4x plus 4x is 8x. And then bring down the next term, which is plus 5. Divide again. What can you multiply by 3x squared? Sorry, by 3x squared to equal 3x squared? 1. Multiply through. 1 times 3x squared is 3x squared. 1 times 0x is 0x, and 1 times 1 is 1. Subtract. And then distribute the negative. Adding down, 3x squared cancel. 8x plus nothing is 8x. 5 plus negative 1 is 4. I have nothing left to bring down. So that tells me that 8x plus 4 is my remainder. So when I'm going to write my overall solution here, when I have a remainder, my quotient was 2x squared minus 4x plus 1 plus my remainder is 8x plus 4. And that goes over the original divisor, which was 3x squared plus 1. This is my answer. Our next example uses long division again. This time we're looking at long division when I is involved, when we have imaginary numbers involved. So let's go ahead and write the problem. Here's the problem written. There were no powers skipped, and it was already in descending order. So we are now ready to apply the algorithm, daddy, mommy, sister, brother. Divide. What can I multiply by 2x to give me 2x cubed? That would be x squared. Multiply. X squared times 2x would give me 2x cubed. X squared times 7i would be 7ix squared. Subtract. I'm going to distribute in the negative. I notice 2x cubes cancel. 7ix squared minus 7ix squared also cancel. And so I have 0 for my leftovers here. The next step is bring down 8x. And when everything cancels, when you do subtraction, you can go ahead and bring down 2 terms. Okay, so now I'm ready to divide again. What can I multiply by 2x? That gives me 8x. Well, 2 times 4 gives me 8x. Multiply. 4 times 2x is 8x. 4 times 7i is 28i. Subtract. Distribute in the subtraction. Everything cancels. I'm left with no remainder. So my quotient and my answer is just x squared plus 4. No remainder. That part is not necessary if you have no remainder. The next question asks me to use synthetic division to determine if the given value for k is a 0 of this polynomial. If not, determine p of k. I'm going to use this to introduce synthetic division, but I want to show you also the remainder theorem with this example. You will find that the remainder theorem will enable you to solve this and answer it faster than synthetic division, though I do want to introduce synthetic division here. So using synthetic division, it's asking if negative 5i is a 0. Negative 5i, in using synthetic division, is going to become what we call the multiplier. It goes in a little backwards L. The polynomial, we want to make sure the terms are in descending order, and we're going to write the coefficients of the polynomial. So my first coefficient in front of x squared is 6. My coefficient in front of x is this entire the entire term 2 minus 5i with a negative in front of it. So if I take the negative and distribute it, it's going to be negative 2 plus 5i. That's my second coefficient. My third coefficient is actually the constant term, and it is 125 minus 10i. So I write my coefficients in descending order, and then the synthetic division process begins. To perform synthetic division, our first step is to bring down the first term under the line. And then I like to say that any number that comes under the line in synthetic division gets multiplied by our multiplier. So negative 5i multiplied by 6 gives me negative 30i. Our next step is to add down. So negative 2 has nothing to add to it, but 5i minus 30i is negative 25i. And any number that comes under the line is going to get multiplied by our multiplier. So negative 5i gets multiplied by negative 2. So negative 5i times negative 2 is positive 10i. And negative 5i times negative 25i is positive Let's see, 5 times 25 is 125i squared. 125i squared. And what do we know happens every time we get an I squared? We multiply by -1. So this essentially becomes -125 plus 10i. Add down, and you should find that 125 minus 125 cancels. -10i plus 10i cancels. You're left with a remainder of 0. So the question says, is k a 0 of the polynomial? Well, if I get a remainder of 0, then I would say yes, it's a 0 of the polynomial. Now, the next part of the question is, if you're going to answer no, if I get any number other than 0 here, if my remainder were 3, or anything that's not 0, then I would say no. Okay? But it says that if you choose no, a box will be displayed for you to submit the value of P of k. So if you say no, the value of P of k is the remainder. So P of k would be 3 if I had gotten 3 for a remainder. Of course, I didn't get 3 for a remainder. So the P of k in this example is 0. I do want to show you that was using the process of synthetic division to come up with the remainder. You could use a theorem called the remainder theorem that would also enable you to come up with the remainder. And the remainder theorem works like this. You would just take k and substitute for x in the function. So if I were to substitute for x, I would say P of -5i. I would do 6 times -5i squared minus 2 minus 5i times -5i. Notice I'm just replacing all the x's with -5i plus 125 minus 10i. And then I would simplify this expression. Well, it's harder when you have i's, but it's definitely doable. -5i squared would be 25i squared, which becomes -25. -25. That gets multiplied by 6. Minus, let's see, -5i multiplied by 2 is going to be -10i, and -5i multiplied by -5i is 25i squared, or -25, plus 125 minus 10i. Okay, then if I continue simplifying here, 6 times -25 is -150. The negative gets distributed here, and I get plus 25 plus 10i plus 125 minus 10i. Combining like terms, 10i and -10i cancel. -150 plus 25 is -125. And I combine that with positive 125, and that cancels. So I get 0. So P of -5i simplifies to equal 0. Anytime it equals 0, then yes, it's a 0 of the polynomial. If it equals anything other than 0, it's going to equal that remainder. So for example, if I substitute in -5i and I get 3, then my value of P of k is 3. I could say, if I had gotten 3 here, I would have said no, and then a box would pop up for me to input what P of k is. P of k would be 3. So you can complete this problem using synthetic division, or you can use the remainder theorem, which just means substitute k in for x. See if you get 0. If you get 0, yes, it's a 0 of the polynomial. If you get anything else, no, it's not a 0 of the polynomial. Okay, next, it asks me to use synthetic division to rewrite the fraction, or to divide, basically. When can I use synthetic division as opposed to long division? Because synthetic division seems to be really nice. Synthetic division can be used if you have x to the first power, and that's the highest power that you're dividing by. Also, the leading coefficient is 1, or the number in front of x has to be 1. If it doesn't meet those two criteria, we would use long division. But since I meet the criteria, I will use synthetic division. In synthetic division, I'm going to take the number that is either being added or subtracted from x, change its sign, and that is the number you're testing to determine if it's a 0. So change the sign. It says x minus I. I will use positive I as my multiplier. Then I'm going to write the coefficients of the polynomial in descending order. So 3x cubed minus 6i x squared plus 4x to the first, and then my constant term is this 3 minus 3i, all is one term. To perform synthetic division, my first step is to bring the first number under the line. Any number that comes under the line gets multiplied by the multiplier, so I times 3 gives me 3i. Then I'm going to add down. Negative 6i plus 3i is negative 3i. Then I'm going to multiply by the multiplier. I times negative 3i is negative 3i squared. I squared is equal to negative 1, so this becomes positive 3. Add down. 4 plus 3 is 7. Multiply again. I times 7 is 7i. Add down. 3 plus 4i is what that simplifies to be. Now, the last term is always going to be the remainder. I will also say when you're writing the answer, if my original dividend starts with x to the third, and you're dividing by x to the first, you subtract 3 minus 1. So you're going to begin your answer with 1 power lower than x to the third. So my answer will begin with 3, here's my coefficient, x to the second, 1 power lower than x to the third. My next coefficient is negative 3i, go down 1 power, x to the first. My next number is going to be a constant, plus 7. And my last term is my remainder, plus 3 plus 4i, and that goes over the divisor, which was x minus I. X, oops, undo, over x minus I. Here is my complete answer. The last thing we need to learn in this lesson is how to construct a polynomial function. So, this is telling me that my polynomial function is second degree. That means x squared. But do you know what else x squared tells me? The ends either point up or the ends point down. It tells me what the zeros are. The zeros are negative 6, so that corresponds to a factor of x plus 6, sign change. And another 0 is positive 5, so that corresponds to the factor x minus 5. Notice the sign change, f of x. And this is really the part we have to decipher. It goes to negative infinity as x approaches negative infinity. Well, x-axis approaching negative infinity is moving this way. So as you move further left on the graph, then it tells me it's going to go down to negative infinity. So as you move further left on the graph, it's going down. Since it's second degree, there's the general shape of this graph. So it's not smiling, it's frowning. And how do I mathematically say that it's frowning? I put a negative in front. So the first thing is taking the zeros, creating your binomials. Secondly, deciding, is this a positive or a negative? It's negative, okay? Now, to construct the function, I'm just going to simplify. So I'm going to use FOIL. I get x squared minus 5x plus 6x, that's plus 1x, minus 30, and then distribute in the negative. So f of x equals negative x squared minus x plus 30. This is the function that meets the criteria. Second degree, x to the second power. Zeros are negative 6 and 5, and it goes to negative infinity as x approaches negative infinity. So it's got to be frowning. This will be our last example. Again, we're constructing a polynomial function. This time we're constructing a function that is third degree. When it's third degree, that means x cubed. That means the general shape is this if the leading coefficient is positive, or this if the leading coefficient is negative. So that's the general shape. The zeros are -3, -2, and 1. So I'm going to begin. F of x equals x plus 3, notice the sign change, x plus 2, notice the sign change, and x minus 1, notice the sign change. Okay? I also could have some sort of coefficient. This one could be stretched or compressed because it gave me a specific point, 212. So I'm going to say there's some number a that could be multiplied by this to make this go through the point 212. All right. Okay, so I'm going to begin simplifying by foiling the first two binomials. So f of x is going to equal a times x squared plus 2x plus 3x is going to become plus 5x plus 6. I'm also still needing to multiply by x minus 1. Next step, I'm going to multiply x minus 1 by that trinomial. So f of x equals a times. If I take this x and multiply it back by all three terms, I get x cubed plus 5x squared plus 6x. Then if I take the minus 1, multiply it back by all three terms, I get minus x squared minus 5x minus 6. Let's clean up and combine like terms. F of x equals a times. X cubed has nothing to combine with it. 5x squared minus 1x squared is 4x squared. 6x minus 5x is 1x minus 6. Okay, last we're saying this particular graph has to go through a point 212. So that means if I substitute in f of 2, I'm going to get 12 for an answer. Here's how I find out how it's been stretched or compressed. My answer here would be 12 if I substitute for x 2. 2 cubed plus 4 times 2 squared plus 2 minus 6. So now I simplify this. 2 cubed is 8. 2 squared is 4, and 4 times 4 is 16, plus 2 minus 6. 8 plus 16 is 24, and 24 plus 2 is 26, and 26 subtract 6 is 20. So that means if I want to know what A is, my stretch or compress factor, I divide by 20. And A would equal 12 over 20 reduces to 3/5. There is a compress factor of 3/5 on this function. So here's how I write my overall answer. F of x equals my compress factor 3/5 multiplied by, what were my zeros? X plus 3, x plus 2, and x minus 1. X plus 3, x plus 2, and x minus 1. And it will accept your answer just like this. It will not make you substitute that in or simplify any of that multiplication. So this is the answer that you have to input. But the big deal was you had to solve for A. And this process shows you how that worked. So I hope that this video has helped you with our learning objectives for the lesson. Our objectives were to learn about the division algorithm. I think we got that. Daddy, mommy, sister, brother. The remainder theorem, that's where you can take a potential zero, substitute it in, and see what the remainder would be. polynomial long division and synthetic division. And we've talked about constructing polynomials if you're given specific zeros and criteria. So good luck with your lesson. I hope these notes help you. Watch it back as many times as you need to. Good luck.